Today I'm going to discuss about developing a obstruction sensor using ultrasonographic module using the Arduino board. Here what we are going to do is we are going to use ultrasonography to identify an obstruction. Now this is particularly helpful when there are two robots which come and they might collide with each other. They should be able to understand that there is an obstruction even when they are walking or when they are moving. Even unmanned vehicles, they will be using this technology where ultrasonography may be used for identifying what is the obstruction and to what level or what dimension that particular obstruction is. Here we are going to do a very simple project regarding understanding whether there is any obstruction or not. This project will primarily be useful for for robots or robot cars which are self-driven and which will be able to identify the obstructions, or it may be also be used for as a medical device for blind people where they can attach this to a stick to identify whether there is an obstruction before them or not. So you can find a lot of usage with this. Now, before making you understand or before giving you a demonstration regarding this particular project, I would like to discuss certain things which are related to physics. Since I'm going to use ultrasonography, let me tell you, it's a sound. So now, by definition, what a sound is a vibration. Sound is basically a vibration that propagates as an acoustic wave through a transmission medium, which may be a gas, which may be a liquid, which may be a solid. Now, when I'm talking about an acoustic wave, human beings may have the sensation or may not have the sensation of the sound. Although we know that anything which vibrates in a transmission medium is bound to create a sound, but it is not necessary for the human physiology to able to perceive the sound. And there are a lot of things, biological factors for which it is responsible for. But anyway, there is a hell lot of frequency of sounds which can be generated. But out of this, human audible range is 20 hertz to 20,000 hertz or 20 kilohertz. So 20 hertz to 20 kilohertz is the audible range for human beings. Below 20 hertz we call it infrasonic range, and more than 20 kilohertz we call it ultrasonic range. Now, in this ultrasonic range, there are a lot of things which we need to discuss. In this particular project, we'll be using this ultrasonic range. Now, let me tell you, there is a lot of beautiful things even happening in nature when it comes to ultrasonic sound. 20 kilohertz to 20 megahertz is basically used in nature by animals for echolocation. This is particularly used for locating a particular prey, or they are able to understand. There are animals which are able to understand whether there is any kind of obstruction before it or not. And 2 megahertz to 200 megahertz is used for medical equipments for different kind of diagnosis. As I was telling you, animals uses echolocation for identifying where their prey is, where there is an obstruction before it. Echolocation is a process of sending out a high frequency pulse of sound which is reflected off solid objects in the environment. So this is what happens with echolocation. Bats uses echolocation. Echolocations are also sometimes called sonar. So bats uses echolocation. What happens is, suppose there is a bat, which basically won't be able to see. That bats are usually, blind, although they have eyes to an extent, they won't be able to see. So what they do is to identify a prey, they emit an ultrasonic sound, which is not audible for human beings. And what happens is this particular ultrasonic sound, it starts propagating, and when it reaches that object, it gets reflected back. And the time or the duration to which this particular sound gets emitted, travels this distance, touches the object and gets reflected back, it is able to understand the obstruction, or it is able to understand the prey, the size of the prey, the distance at which it is. So this is how it uses sound as a way of, seeing. So bats are a very common example. In this project, which I'm going to develop, we are also going to use a concept similar to bats when they are, going to fly using the sound. They use the sound for seeing. What we are going to do is we are going to emit an ultrasonic sound. Say we are going to emit, this is the place from where we emit an ultrasonic sound, and this sound, when it comes to an object and it gets, again reflected back, this particular time we are going to calculate, and then we are going to identify to what distance the particular object is from the source. So this is what we are going to do. But before that, let me tell you what are the components which we are going to use. We are going to use the Arduino board. We are going to use the Arduino board, Arduino Uno. This is the board which we are going to use. And then we have few jumper wires. Then we have the breadboard, and I have this buzzer. This I have salvaged from an old telephone. It produces a good amount of sound. Now, the primary instrument which we are going to use is this. This is HCSR04 ultrasonic sensor module. This particular module is basically used for emitting and receiving the ultrasonic sound. Now, this is a basic instrument through which we are able to transmit and receive the ultrasonic sound. The ultrasonic sound will be transmitted from this cylindrical shapes. It will be transmitted from here, and then there is another receiver where the ultrasonic sound will be received. You can see there are four pins with the names VCC, Trig, Echo, GRND. That is ground. VCC is for the voltage which needs to be provided, and GRND is for grounding it. And Trig is which we need to set for setting a ultrasonic frequency from this emitter, and Echo is the time. So here there are four pins, namely VCC, then we have Trig, we have Echo, and then we have ground. So VCC will be plugged into the 5-volt pin of the Arduino board, and we have the ground which will be grounded to the Arduino board. The trigger pin is responsible for emitting or making this particular device to emit an ultrasonic sound, and echo pin is used to receive the time which this particular sound needs to propagate from the source till the object where it gets obstructed and reflected back. So it's double the particular distance. So this entire time it calculates and it gives it to us, and then we have to make a certain amount of calculation to get the distance from the object till the source. This is what we are going to do. Now this particular device, you can get it in online in Amazon, or you can get it in Flipkart. It costs something around 150 to 200 rupees. That is what I have seen online. So this particular device, you can get it that way. And you have this buzzer which actually cost 20 rupees. I have salvaged it from a telephone. And the breadboard, Arduino, and the USB cable which we are going to use it. Now what is important is the calculation of the distance. Now remember, what we are going to do is there are four pins which I've already mentioned earlier, and VCC is for the voltage, and ground is for grounding it to the Arduino. Now in the trigger pin, what we are going to do is we are going to set it as high for 10 microseconds. For 10 microseconds, we are going to set it high. Now what is going to happen is it's going to emit an ultrasonic sound, which is 8 cycle sonic burst. It's going to send that, and this particular sound travels, and when it reaches an object and gets reflected back, this entire time is being calculated in microseconds by the echo pin, which we are going to calculate it from our program. In our program, the entire duration comes into the variable named duration from the echo pin, and then what I do is time into speed will give me the distance. So time is the duration, it is being multiplied by the speed I have taken it as 0.034. The reason behind this is I have assumed the speed of sound in air to be as 340 meter per second. When it gets converted to microseconds, it comes to 0.034 microseconds. So that is why what I am doing is that particular time I am multiplying with the speed of sound traveling in air, that is 0.034, and I am dividing it by 2. The reason behind this is I am dividing it by 2 is because it takes double the time, because the sound is going to get transmitted from the emitter, it travels, reaches the object, and when it gets back to the receiver, it's double the time. So that is why what I am going to do is this distance is twice, so I am dividing it by 2 to get more or less the exact distance between the source and the object. This is what is happening over here. So here is the final installation. You can see the circuit. Here is the Arduino board. Here is the ultrasonic sensor module, and here we have the buzzer which are attached according to the circuit diagram which I have already mentioned before. You can see in my blog regarding this, and I'll give you a demonstration. Here according to the code, what I have done is, if the distance is less than 10, so if the distance is less than 10, here this is what I've done. If the distance is less than 10, I am starting with the buzzer. The buzzer is being repeatedly set to high for 1 microsecond, and after that it is again lowered for 1 microsecond, and this process continues for 100 times. So there is a loop which actually puts this high tone and low tone, high tone and low tone alternately. So whenever the distance is less than equal to 10, and rest of the code I've already discussed about it. And here is the demonstration. I have compiled the code, and then what I'm going to do is I'm going to upload it. And now you can see I'm putting my hand before the sensor. Now the sensor, it states that if it is less than 10. So here you can see my hand has come near. So it is less than 10. So it starts beeping. The buzzer starts beeping. Again, when I go beyond that 10 centimeter, so it again comes in. The buzzer becomes switched off. I can always increase this distance. Let me put it at 20. So indicating that it's 20 centimeter. So I'm going to compile the code once again. And I'm going to upload it to my Arduino board. And here you can see once again I'm bringing my hand, and here you see the distance. The distance is here. Prior to this, the distance 10 centimeter was somewhere here, and now the distance is out here, which is less than 20 centimeters. So it starts able to identify the obstruction before it. So this is the entire circuitry. Hope you enjoyed the entire video.